So I've shown you how we can calculate confidence intervals on the slope and intercept for straight line regression, and I've shown you how we can calculate confidence intervals on the mean response. In this screencast, I'm going to show you how we can create prediction intervals for straight line regression. And this is actually more common than confidence intervals on the mean response. Like confidence intervals on the mean response, the regression tool in Excel does not output the prediction intervals on a future observation. So let's continue with our example. We have porosity as a function of temperature. So far, we have calculated confidence intervals on the slope and intercept, and these are output by the regression tool in Excel. And you've also learned how to calculate confidence intervals on the mean response, and these are not output by the regression tool. Our dotted line here is just our line of best fit, and that's our best estimate for the true model that relates porosity to temperature. And so we can calculate confidence intervals on the slope and intercept. We can also put together confidence intervals on the mean response. For example, if we chose over and over temperature of 1300 many times, there's a distribution associated with that. You're not always going to get the same number. And that distribution is centered about a particular mean, and that's known as the mean response. In this screencast, you're going to learn how to calculate prediction intervals on a future observation. Instead of being 95% certain, for example, at 1300, that the mean of that distribution is a certain value, the prediction interval tells you now if we take a single future observation, let's just say at 1300, we're going to be 95% certain that the porosity lies between two values. We're not performing a confidence interval on the mean response, which we've done previously. We're calculating a confidence interval or a prediction interval on a future observation. So a prediction of a new observation is more common, even though it's not output by the regression tool in Excel. A 100 times 1 minus alpha percent prediction interval on a future observation y naught at the value x naught is given by this equation. So it's quite messy, but it's very similar to the confidence interval on the mean response. Our confidence interval on a future observation is centered about the prediction, the estimate. The estimate can be obtained by this formula down here, where we're just taking our x naught, the independent variable, and plugging it into the line of that equation. And we're subtracting or adding a half interval given in this equation. The difference between this and a confidence interval on the mean response is that now we have a 1 added inside of our standard error. So we can calculate this in Excel just like we did for a confidence interval on the mean response. A lot of these things, if you've been watching the previous screencast, I've already calculated in my Excel spreadsheet. So I'm just going to carry this over and we're going to continue and calculate a prediction interval on a new observation. So here we are over in Excel. In the previous screencast, we calculated confidence intervals on the mean response. Today, we're going to calculate a prediction interval on a future measurement. Let's just say in the future, we choose a temperature of 1200. We can compute y hat. Y hat is just equal to beta naught plus beta 1 times our x naught, our 1200 there. And that just tells us kind of the middle or expected value of the response. But now we need to calculate the prediction interval here. So I'm going to use as my basis y hat. I'm subtracting t alpha divided by 2 with n minus 2 degrees of freedom that we calculated previously. And now I'm going to multiply by this big old term here in our half interval. And you should always double check, but I'm pretty confident that this is correct. I press enter. I can always drag this down, and I'm just going to add instead of subtract. So I'm adding my half interval. That means that if we took a future measurement at 1200 degrees Celsius, we would be 95% certain that the output would be between 11.1 and 31.5. Like the confidence intervals on the mean response, the prediction interval is narrowest when you get closer to the average. So if I went to an x naught of 1400, which is x bar, the interval width is a little bit smaller than it was at 1200. This is how you can compute prediction intervals on a future measurement or a future observation. And again, this is not output by Excel's regression tool.